Objective 4 says, know the ways that reaction rate can be increased and explain why each increases the reaction rate. So here's the specific ways to do it. The first one is what's known as the nature of the reactants. So this one you really can't change in the lab. If you're told you have to react A with B, you don't really get a choice about it. But if you're just told, find a way to remove the tarnish from silver, and you're given the option of what the second reactant is, if you find a more reactive element, then the reaction will proceed quicker. So nature of reactants, sometimes you have control over, sometimes you don't. But if I asked which metal would react more quickly in HCl, magnesium or gold, you should know when you look at a metal reactivity series that magnesium is a far more reactive metal than gold is, so it would react much quicker. The second one is concentration. Now, sometimes people say add more reactant. That's not the same thing. This is different than volume. Volume is just adding more of the same stuff. So that doesn't affect the reaction rate because it's just more with the same crowding in it. So you have to use a more crowded solution or a more concentrated solution in order for this to make a difference. So using a more concentrated solution means you have more reactant particles in the same space, so more collisions are going to occur. Surface area is similar in that now you have a solid reactant that you break into smaller pieces, and when you do that, more reactant particles are exposed or available. So they're not being protected by the outer layer of particles. There's more reactive particles exposed and ready or available to be collided with. The other two, if we go to the next slide, are temperature and a catalyst. Temperature, if you increase the temperature, it's going to help in two ways. It's going to increase the number of collisions, but it's also going to increase the energy of the collisions. So it really helps out two of the three requirements. And then the last one, catalyst, because I said the ways reaction rate can be increased, I didn't include inhibitor here, but inhibitor would be just the opposite in ways to decrease the reaction rate. But a catalyst increases the reaction rate in a different way. Instead of affecting the number of collisions, it decreases the amount of energy needed. And it might do that by making the orientation easier, making the sweet spot easier to hit, or it might put something in the way. It might take something out of the way, I should say. It's kind of like letting a little kid move closer to the basket to shoot a free throw and bringing the basket down lower and making the basket itself bigger. All those things make it far more likely that the kid will get the ball through the hoop. Doesn't give the kid any extra shots, but it does many things to make it more likely that his shot will go through the hoop.